So you're in chemistry class, you might wonder, what is it? How is it different from other disciplines, other studies? Chemistry is, of course, a science, and it's sometimes called the central science because it lies between physics and biology. Physics would be the study of the forces, motion, and energy between particles and in nature and in the whole universe. Chemistry has to do with the nature and properties of matter, material things. And biology has to do with the study of life and organisms. In chemistry, we're going to focus a lot on, or make a lot of use out of the periodic table. Here's an example of one. It is not quite totally updated because since this was made, they have given names to, I believe, several of these elements out here, like 117 for sure, and maybe even 118. So this periodic table, though, is a summary of at least the last 200 years of work in chemistry, understanding the nature of atoms and elements, and then how they interact with each other to make compounds and so forth, as the development of these things. But we can, you probably know already that the periodic table helps us out because it organizes chemicals, elements, I should say elements, according to their similar properties in groups or in columns. We're going to talk about that a lot this year. I also want to point out, you may have heard of nuclear reactions. You may think of them as chemistry, but technically nuclear reactions are not chemical reactions because chemical reactions are those kind of reactions that involve electrons becoming newly gained, lost, or shared, whereas nuclear reactions deal not with the electrons in the electron cloud of neighboring atoms or molecules, but they deal with protons and neutrons in the nucleus, either being gained or lost or split. So, branches of chemistry. Probably the most foundational or fundamental is physical chemistry. As we already mentioned, physics deals with forces and energy, but physical chemistry deals with forces and energy involved in chemical reactions or in interactions between molecules at the molecular level. Inorganic chemistry studies all the compounds made of all the elements that are not compounds made of carbon attached to hydrogen. So inorganic chemistry deals with the whole periodic table, while organic chemistry deals with the myriad of compounds, and there are a lot of them, that contain carbons that are attached to hydrogens inside them. Organic chemistry. So then analytical chemistry is about improving measurement, about making techniques and devices that allow us to more finely detect, more sensitively detect things. And biochemistry is the chemistry of life. So in physical chemistry, we would study kinetics. We won't do that this year in pre-AP chemistry, but we will study thermodynamics, which you can see thermo has to do with heat. It actually has to do with energy being gained or lost in a chemical reaction. So we're going to touch on that this year. And also the intermolecular forces of attraction that happen to be there between different molecules or atoms. Those are things that fall into the category of physical chemistry, and we're going to do some of that this year also. Inorganic chemistry, as I already mentioned, deals with any of the reactions or compounds made from any of the elements on the periodic table, except for compounds that have carbon attached to hydrogen. So all the rest of them are fair game. And so here you can see that at the college level and higher, they'll be studying crystal structure of various compounds and so forth, or they may be working on tweaking materials. This is supposed to be yttrium, copper, barium oxide, and this was one of the early superconductors that people thought had promise for speeding up electrical currents, making really fast electric circuits in our devices. They're not yet practical for us, but there's research on the way concerning these things. And then precipitation reactions are just one example of some of the kind of reactions that are inorganic chemical reactions, and we will be studying some of those this year. Organic chemistry deals with carbon molecules that have carbon with hydrogen attached, And here are the different kinds. You may have heard of some of them. Of course, you've heard of alcohols. You probably have heard of aldehydes, like formaldehyde. You may have heard of acetone, which is a ketone. You've probably heard of ether. And you've heard of acids. I don't know if you've heard of carboxylic acid, but if you've dealt with vinegar, you've dealt with the carboxylic acid. And then there are amines. So anyway, these are various categories. There are more, but these are various basic categories of organic compounds, and we're not going to deal with those in pre-AP chemistry, and you wouldn't in on-level chemistry either for the first year of chemistry. Now we will in AP and dual credit chemistry. Analytical chemistry just has to do with improving how we can detect compounds, and it might be a qualitative analysis or a quantitative analysis. Qualitative just to figure out what's in there, and quantitative to figure out how much. And so we will be doing some of this year. And then biochemistry is kind of a special category of organic chemistry because most of the compounds that are in living systems, you can see bio has to do with life, right? Most of the compounds that are in living systems are organic compounds, but biochemistry just focuses on the actual compounds that are found in living systems. And so that would be like proteins and nucleic acids and lipids and carbohydrates, things like that. And one of enzyme characterization is a big feature of biochemical studies. And they also, maybe you've heard of, maybe you remember from biology learning about the Calvin cycle or other biochemical pathways. Well, those were figured out by biochemists, and that's what biochemists do. That's a part of what they do. Of course, all these fields are much deeper and more interesting, but this is just a broad overview of the different basic branches of chemistry.